We spent all year taking apart a ton of devices, and along the way, we spotted some wildly cool things that are usually hidden from people who only ever see the outside of their devices. Here are iFixit's most interesting teardown finds of 2021. First up, just how in the world do you make a foldable device waterproof? The first time we tore down Samsung Z Flip, we subjected it to a less than scientific dust test, which it failed spectacularly. This year, Samsung didn't address dust resistance, but they did release not just one, but two foldable devices with IPX8 water resistance. Curious how they were able to manage this feat, we dove right into teardown mode after giving them a long soak in our fish tank. Turns out, Samsung used similar waterproofing methods we found in their other devices. Adhesives are used to seal up the devices on both the front and back, which on the plus side keeps them safe from water, but on the downside makes them a pain to open for repairs. For the parts of the phone that have to get exposed to outside elements like water, Samsung used some ingenious engineering to keep things dry. Rather than try and keep water all the way out, they let it get under the foldable display but keep super tight tolerance for the communication cables underneath with special cured-in-place gaskets that solidify when exposed to air to keep all the boards and chips below dry. From a repair point of view, these devices are frustrating and complicated, but it's still a fascinating solution to a foldable durability problem. Next up, this was the first year in a really long time that we saw a repairable MacBook Pro. Kind of. It's been almost 10 years since the MacBook Pro had an easily replaceable battery, but thankfully with the all-new M1 MacBook Pros, that's exactly what we got. After years of sticky, messy, and laborious battery removal, Apple finally gave us the perfect gift for this holiday season: stretch-release adhesive strips. The 2021 M1 MacBook Pro comes with several easy-ish to remove adhesive strips that makes battery removal relatively quick and painless, if you know where to find them. While the 2021 M1 MacBook Pro might earn a medal from us for most improved repairability this year, it won't win for most repairable. It still has tons of non-standard screws keeping the average consumer out, and its integrated storage and memory give it a limited lifespan. If you were looking for new and interesting display technology, the 12-inch M1 iPad Pro had you covered. This year, the 12-inch iPad Pro gained not only a blazing fast M1 system on chip, but also a new liquid Retina XDR display, powered by over 10,000 mini LEDs. To get a closer look at just how that new mini LED technology worked, we tore down the display itself, diving through layers of glass, filters, and finally the backlight. The Liquid Retina XDR replaces the standard display backlight with a giant grid of tiny LEDs directly under the screen that can be individually controlled. This means the screen can get brighter, but also more importantly, the LEDs positioned where the pixels on the screen are black can effectively be off, greatly increasing contrast. Not only is this screen great looking, but it's also got a lot going on under the hood. Just as a side note, we also found some interesting things with the iPad Pro's smaller sibling, the iPad mini, but those findings were not all that positive. This was a highly anticipated device that was disappointing to many people thanks to its jelly scrolling display quirk. We dug into the issue to uncover that this is actually something you can easily replicate with any LCD display. The iPad mini just had the perfect storm of factors working against it that made it easy to spot. Check out that video for the full breakdown. Next up on our list of most interesting teardown finds is the mystery of the delayed Apple Watch. The Apple Watch Series 7's release date was uncharacteristically not available for about a month after the new iPhone 13, and we wanted to know why. The design only changed slightly, contrary to many of the leaks we saw throughout the year, which made us curious. Why would it need to come so much later? What caused the delay? To find out, we recruited our friend Tobias from Instrumental, a former Apple engineer and expert on supply chain issues. After tearing down the Series 7 with us, we found the main suspect for the delay was the new, slightly larger display.
Looking at the back of the display, the border size is typically constrained by both the touch flex exiting out the top and wrapping around, and then the OLED flex bending around at the bottom. And what you can see on the new Series 7 is they've removed the touch flex on the top and consolidated both the touch and the display signals down at the bottom. And lastly, they've added on this plastic frame that helps with structural support and allows them to actually shrink the borders down to this new narrower size. And because of the inherent complexities in the display supply chains, combined with this radically new display design, I'm fairly certain that this was the cause of the Apple Watch delays.
It turns out, small changes like increasing display size can cause really big production issues. Yet another reminder of how intricate and complex these devices are. With most smartphone makers turning to adhesive for waterproofing and ease of assembly, we're always excited to see Fairphone's take on what a modern smartphone can be when it's designed from the ground up with repair and sustainability in mind. That said, one of the highlights of our year was getting our hands on the brand new Fairphone 4. Seeing a phone that prioritizes repairability from a company who's committed to providing spare parts and support for 5 years is a real treat these days. This Fairphone is extremely easy to open, has a battery and screen that are easily replaceable, and has a completely modular interior design with easily replaceable components. All of this in a form factor that's not much bigger than the iPhone. Lastly, while it wasn't officially a teardown find, we did have a lot of fun taking apart the PS5 DualSense controller to uncover why it, and pretty much every other joystick, eventually suffers from drift, where the joystick moves by itself. It turns out, most console companies use similar joystick modules in their controllers. These modules all rely on similar methods to obtain the position of the joystick. Potentiometers measure the position of each axis with an electric circuit. The problem is, these circuits are made with mechanical components that rub against each other and will eventually begin to wear out, causing drift and other similar issues. That's it for this roundup. Was there a device you wanted to watch us tear down this year that we didn't? Let us know in the comments and we'll add it to our list for next year.